talk 2 that we've got today. We're going to start off with Nick Frichette. He's a senior security researcher at Datadog, where he specializes in AWS offensive security. And today Nick's going to be talking about how to evade logging in the cloud. His talk's called Evading Logging in the Cloud, Bypassing AWS CloudTrail. Please give a warm welcome.
Hey everyone, thank you so much for being here. Welcome to my talk on bypassing CloudTrail. Hope you're excited to hear about cloud security vulnerabilities and vulnerabilities in cloud service providers. It's one of my favorite topics. My name is Nick Frichette. I'm a security researcher over at Datadog, where I work on our cloud security products. I spend a lot of time coming up with ways that adversaries can more effectively compromise and exploit cloud resources, and from that, how do we detect that behavior or hopefully prevent it entirely. I'm also the creator of Hacking the Cloud, which you may have seen. It's an open source encyclopedia of offensive security techniques that you can use in cloud environments. For this talk, we have quite a lot to get through. We'll start with a quick introduction to what CloudTrail is and why we care about it. And then we'll take a look at the internals of the AWS API, getting a little bit of familiarity with how it works so that we can start applying that knowledge to bypassing CloudTrail. Over time, I've found a number of vulnerabilities that have allowed me to bypass CloudTrail in some way. Everything from simple permission enumeration up to and including just interacting with an individual service while just completely avoiding logging. Now, it's important to note that when we talk about a CloudTrail bypass, this is not a misconfiguration. This is not something we can account for by changing our CloudTrail setup. It's nothing galaxy brain like, hey, if I turn CloudTrail off, then I'm bypassing it, or anything like that. A CloudTrail bypass is very much so a flaw on the AWS side of the shared responsibility model. And as a result, it's ultimately up to Amazon to fix, mitigate, or otherwise remediate these issues. Now, as I'm sure you can imagine, AWS has a vested interest in ensuring the security of their platform. And as a result, almost all of the specific issues we'll be talking about today have since been fixed by AWS. So think of this talk less from the perspective of, if you're a pen tester or red teamer, here are some specific vulnerabilities you can abuse, and much more from the perspective of, what can we learn from these vulnerabilities that we can apply to future bypasses. And indeed, we'll show there's still a ton of opportunity to evade CloudTrail logging. While the specific vulnerabilities we'll be talking about today have been fixed, the high-level archetypes or categories are still absolutely exploitable. And those, the ones that we'll be talking about are protocol mutation, undocumented APIs, and abusing non-production endpoints. Now, that all being said, I certainly don't want to disappoint my pentest and red team friends. So as a result, a little later on in the talk, I do have some techniques that do still work today and can be used. Now, let's get started. Really quick, what is AWS CloudTrail? CloudTrail is a fundamental security service offered by AWS, and it is responsible for logging calls to the AWS API. Under most circumstances, when an identity in an AWS environment performs in a call to the AWS API, that invocation will create a CloudTrail event. And that event will contain all of the relevant metadata around that invocation. The identity that performed it, the date and time it occurred, the specific service and action that was invoked, the IP address and user agent of the client, as well as all of the parameters associated with that call. And now this, combined with a SIEM or a data lake, makes it super easy for security teams to do automated threat detection of suspicious activities and alert on the goings-on in their environment. CloudTrail is fantastic for answering the question of who did what when in an AWS account. Now, by that exact same notion, what's great for security teams is a problem for adversaries. For an attacker, there is a significant draw to want to go after and use stolen IAM credentials. Because with those credentials, they open the possibility for things like privilege escalation, lateral movement, accessing resources, maintaining persistence, and so much more. But adversaries run the risk that just about anything they would do with those credentials would ultimately get logged to CloudTrail and later on analyzed by a SIEM, a data lake, or something else, getting them caught. And so this is the motivation behind the research we're going to be talking about today. Adversaries want to leave as small a footprint as possible to try and evade detection. And you can't really get much better than leaving no trace at all. And it's important to note that from the victim's perspective, if an adversary can invoke actions against the AWS API without leaving any trace in CloudTrail, that attacker is invisible. Defenders have no way of knowing that this activity has occurred. So let's talk a little bit about how the AWS API works. One of the major talking points, or one of the major design focuses at AWS, is something they refer to as model-first design. And what they mean by this is when they create a new service, before they write a single line of code, they first create a model that describes everything about that service. What its operations will be, what parameters it'll need, and so on. Now, as a result, this model-first design carries over well into production. And as a result, we can actually extract out those models from the SDK. What you see on the slide here is a sample, the top portion of the model for the Secrets Manager service that I pulled from the Botacore Python library. Now, these models are incredibly important because if you want to interact with the AWS API, you need basically all the information contained within this model. When it comes to things like undocumented APIs, finding these is basically half the battle. So there's a lot of important parts in the model. For our purposes today, by far the most important part is something called the protocol. The protocol of an AWS API is essentially the format by which the client will serialize requests so they can be properly deserialized on the server. And as we can see here, Secrets Manager uses the JSON protocol, specifically JSON version 1.1. There are 6 possible protocols currently in use by the AWS API. And again, this is simply the format of the request. So to continue our Secrets Manager example, because we know that Secrets Manager uses JSON version 1.1, that tells us it'll always be a POST request. It'll always go to the base path, not /API or anything like that. We know it'll send content as JSON. We know there'll be an X Amazon target header, which is comprised of some terms from the model, as well as the content type header. And for our purposes, this is the most important part, as for the JSON family of services, the content type header is the version of JSON that gets sent along. And so this introduces the first potential for CloudTrail bypass. If the AWS API uses this very rigid, well-formatted structure, what happens if we were to mutate our requests or malform our inputs? Could we cause the AWS API to behave in a way that is advantageous to an attacker? An interesting place to get started with this is simply, well, hey, if there's 2 versions of JSON, what happens if I send the wrong version to a particular endpoint? So for instance, sending a 1.0 header to a 1.1 API. As it turns out, we got some interesting results. Depending on if an identity did or did not have permission to perform an API action, you would get back a different HTTP response code. If you did have permission, you get back a 404, and if you did not, you would get back a 403. And critical to all of this, regardless of the level of permission, none of it got logged to CloudTrail. And so what this meant was for an adversary who has stolen IAM credentials, they could use this technique of changing a single character in a header to silently enumerate what permissions they had access to, all while avoiding detection. And at the time, this applied to over 645 actions across over 40 services. Now, for a little bit of background on why this matters or how we would use this, it's important to note that for adversaries who have stolen IAM credentials, they don't have a very good way of knowing what level of privilege they've just compromised. The keys that they found might belong to the root user and have full access to that AWS account, or they might have literally no permissions at all. And so a common technique or method that adversaries use to deal with this is brute force. They try and see what works. If it succeeds, they know they have that permission. If it fails, well, they know that they don't. Now, the good news for defenders, and one thing I should mention, there's even a handy tool to brute force this for you called Enumerate IAM. Simply run this tool and you will very quickly find out what API calls you can make with a pair of stolen IAM credentials. Now, the good news for defenders in this case is that this behavior is incredibly noisy and definitely easy to spot. It presents itself as a sudden increase in access denied errors in CloudTrail, or you can also pick up on it by an identity performing API actions that has no history of ever doing so before. And as a result, this serves as a golden opportunity to detect suspicious attacker behavior going on in your environment and kicking them out of it. But if we use the method I described previously of changing a single character in a header, none of it would appear in CloudTrail, and adversaries would have a free pass to enumerate hundreds of permissions for tens of services completely silently, all while avoiding CloudTrail. Defenders would lose out on a golden opportunity to detect suspicious behavior, and adversaries get a free pass to move on to their next objective. If you're interested in this topic, I have a ton of additional resources, links, proof of concept scripts at that URL down below. For its time, this was an amazing technique for pen testers and red teamers to silently enumerate permissions and avoid the SOC. Next, I'd like to talk a little bit about undocumented APIs. These have been a very hot topic in the AWS security research community lately, as they have led to some fairly significant vulnerabilities, including cross-tenant ones, and they've been shown to have the potential for CloudTrail bypass. Now, the problem with an undocumented API is, how do you find it? Because it is undocumented, we can't exactly just roll up to the wikis or anything else to figure out what APIs are available. By far the best way that I've personally found to do this has been to abuse the AWS console. In order for your browser to know how to properly format, sign, and configure those requests, it needs to have those very same models that I showed previously. And as a result, what you can do is crawl the AWS console and extract out those models from the JavaScript that gets sent to the client. And interestingly enough, the models that are in the console are not the same ones that appear in the SDKs, and often include internal-only and undocumented APIs. Now, as an example of this, if you were to crawl the console and start extracting these, you would eventually find a service called IEM admin. Now, IEM admin is super interesting, aside from the fact that its name is IEM admin. It's actually likely a service you may have interacted with before, you just didn't know it. If you were to open up your browser, navigate to the IEM page in the console, hit F12 to open the network tab and refresh, you'd start seeing calls to the IEM admin service. Now, another interesting thing about it is that the names of its operations sound vaguely familiar to IEM ones, but not quite. So for instance, IEM admin has an operation titled list access keys from multiple users, which sounds sort of similar to IEM list access keys. Now, again, we can crawl the console, extract out all the information we need, and this gives us a nice list of operations that we can invoke against the IEM admin service. Now, from here, a common trick used by AWS security researchers is, if you find a sketchy API, try and invoke it with a user or role who has no permissions at all. And the reason you do that is because the API that you are calling does not always have a one-to-one relationship to what actually gets invoked on the back end. So to demonstrate this, if you were to call IEM admin list access keys from multiple users, in the resulting error message you get back, you'll see user is not authorized to perform IEM list access keys. And that is a normal documented API. And so it's through this method of using an undocumented API, sort of as a proxy, that we can invoke normal APIs. And of course, if we repeat this process for all of the operations we found in the previous step, we're able to create a map between the undocumented IEM admin operations and the documented IEM ones. Now, the question here is, when we invoke these APIs, what does this look like in CloudTrail? Does it show up as IEM admin? Does it show up as IEM? Does it show up as both? Well, turns out, it showed up as neither, because it didn't show up at all. None of the invocations against the IEM admin service would appear in CloudTrail. And so it's through this method of using an undocumented API that an attacker would be able to make invitations to the IAM service completely silently, all while avoiding CloudTrail. Now, the reason this matters is, again, this is another golden opportunity to detect suspicious behavior. A ton of commercial SIEMs have default out-of-the-box rules for things like suspicious calls to list access keys, list groups, things like that. And even AWS's own Guard Duty has a detection for anomalous behavior that's designed to catch literally this. But because we're bypassing CloudTrail, none of those tools have the opportunity to see this activity at all, and adversaries get a free pass to do what they want completely silently. Now, this specific example has since been fixed by AWS. Any calls to IAM admin will show up as the equivalent IAM operation in CloudTrail, but due to the sheer number of thousands of undocumented APIs, it makes you wonder what other APIs behave in a similar manner. And that takes us to a pretty exciting topic, non-production endpoints. Personally, I think this is the most likely to return future CloudTrail bypasses with relatively little effort, and we'll talk a little bit about why that is. But first, a little bit of background. With the AWS API, the endpoint that you're interacting with will differ on a service-by-service basis and a region-by-region basis. And the format for that endpoint is typically, although not always, servicename.region.amazonaws.com. So to continue our secrets manager example, if you want to talk to secrets manager in the US East 1 region, that's the endpoint you would use. Now, it's important to note that that is an example of a production endpoint. That's what the CLI, SDK, console all use. It's what you're expected to use. It may surprise you to know that there are thousands of non-production endpoints that we may be able to interact with over the internet, and we may be able to authenticate against using our normal AWS accounts. Now, these non-production endpoints exist for a variety of reasons. There are pre-production environments, alpha, beta, gamma, which is part of AWS's deployment pipeline. There's staging, preview builds, legacy, alphabetical ones, and so on. And again, this is just a small subset. There are thousands and thousands of these out there. Now, you might be thinking, okay, cool, but how do I interact with that endpoint? Do I have to manually sign it using SIG-v4? Well, the good news is, no, you don't. At least for APIs that exist within the CLI, you can actually use the CLI for this. There is a handy argument for endpoint URL. Simply pass in the endpoint you want to use, and everything works about as well as you'd expect. Now, non-production endpoints are particularly exciting for a wide variety of use cases related to defense evasion, including outside of CloudTrail bypass. To sort of get us started, to sort of set a base case situation, I'd like to introduce you to KMS-A. Now, this is a non-production endpoint that has access to production resources and does log to CloudTrail. And what I mean by that is, if you were to use that endpoint, if you were to list keys, you would see all the keys you would expect. If you were to modify, delete, or create something via that endpoint, all of those changes or what you created would also show up in the normal production endpoint. It'd show up in the console, and everything would work fairly normally. Additionally, all of it gets logged to CloudTrail. Now, the reason I'm being so specific that this endpoint exhibits the behavior of having access to production resources and logging to CloudTrail is because it's possible for the inverse to be true. There are non-production endpoints that do not have access to production resources and do not log to CloudTrail. Now, to demonstrate this, we have a little bit of a test setup, and I apologize, I recognize the fonts are probably super tiny, so I'll narrate. Here we're performing two API calls. The first is SNS list topics in the US East 2 region. And you see that we get back a topic because there is one in that region. We then perform the same API operation a second time, but this time against the non-production endpoint SNS-gamma. And you see that we get back an empty response. Now, presumably, this is because SNS-gamma doesn't have access to production resources. Hopefully in the same way that your pre-production environment doesn't have access to your production database or anything like that. Now, this is all a bit of a bummer because that non-production endpoint doesn't log to CloudTrail. And so if it did have access to production resources, that'd be great. We could interact with this service completely silently, create, modify, delete, all while avoiding CloudTrail. But just because it doesn't have access to production resources doesn't mean it's entirely worthless to us. If you'll notice, we still got a successful response. It came back empty, so we can't see the resources, but somewhere along the line, IAM took a look at the permissions of the identity performing this API call and said, yeah, you're authorized to do that, and let it go through. And critically, it didn't get logged to CloudTrail. We see only one event because we performed that top one completely normally. It didn't see the second one. And so it's through this method of using a non-production endpoint, very similar to what I described with the protocol mutation, that we can enumerate permissions completely silently. And for my, this raises the questions, if you're an adversary who has stolen IAM credentials, why would you ever use a normal production endpoint that'll log to CloudTrail and probably get you caught when you might be able to take advantage of a non-production endpoint, get the exact same information, and completely avoid CloudTrail? And I should mention, for my pentest and red team friends, this technique still works today, including outside of that endpoint. It works for a variety of endpoints across a variety of services. I did disclose this to AWS, who responded that they're not interested in changing this behavior at this time, which as a result makes it fair game to abuse. And in a few weeks, I intend to release a blog post with the full data set of non-production endpoints that behave this way, along with their associated service. The next potential use case for non-production endpoints that we'll talk about here is something called event source obfuscation. And to be clear, this is super rare. This is probably the rarest combination of attributes I've seen on a non-production endpoint, but here's an example of it working. Again, tiny font, so I'll narrate. We're performing 2 API calls, very similar setup to what we did before. We're doing IVS list channels in the AP Northeast 1 region. And you see, we get back a result because there is one. There is a channel in that region. We then do the exact same operation, but this time using the non-production endpoint, IVS-gamma. And this time, we do get back a result. Presumably, this non-production endpoint has access to production resources. Great. Does it log to CloudTrail? Well, bad news. There's 2 events, so yes, it does log to CloudTrail, but it does it wrong. If you'll notice, the first invocation, the one that occurred at the 19th second, the one on the bottom that we did totally normally, has an event source of ivs.amazonaws.com. Now, that's what we would expect. That's totally normal. The second invocation, the one we used with the non-production endpoint that occurred at the 25th second, has an event source of gamma-starfruit. Now, I don't know what starfruit is, or gamma-starfruit is. I presume it's an internal code name or service name or something like that. And worth knowing, not all non-production endpoints that exhibit this event source obfuscation behavior have an event source of gamma-starfruit. Instead, by far, the much more common format that I've seen is gamma-service name. But starfruit is certainly the most interesting. Now, this matters for 2 key reasons. The first is it's worth knowing that there are a ton of commercial SIEMs that use the event source as a part of their detection rule. And if you were to have a rule for, as an example, this IVS service, when that SIEM goes to evaluate that rule against this event, it's going to compare 2 strings, and they're not going to match. And so this can be a way to evade detection from some SIEM detection rules. The second reason this matters is for forensic scenarios. Post-compromise, post-breach, it's totally reasonable to want to pull all the logs for an affected service during a given time frame. And typically, when you pull logs on a service-by-service basis, you do it by the event source. If you try to pull all the logs for IVS, you're going to miss out on that event that used event source obfuscation. So something to keep in mind if you're involved in incident response or forensic scenarios.
Does it show up on the bill?
Great question. I don't know if I can answer that actually. Let's talk after. We'll see. And finally, the last potential use case for non-production endpoints that's public and we'll talk about today is, as I'm sure you assumed, there's a combination of attributes for has access to production resources and doesn't log to CloudTrail. And that's exactly what we saw in Service Catalog. By simply changing the endpoint we're interacting with, nothing would appear in CloudTrail. Both read and write operations, we can modify things completely silently. And this is particularly concerning for a service like Service Catalog, whose entire purpose is to be a centralized location to store infrastructure as code templates that you would then deploy out across your enterprise. Imagine a scenario in which an adversary gains a foothold in that account with privilege. By literally changing the endpoint that they're talking to, they could backdoor or modify those portfolios and applications completely silently as they get forced out across the enterprise. If you're interested in Service Catalog, there is actually a talk on this 2 sessions from now for using it for privilege escalation scenarios. Imagine how scary that would be if you could also evade all detection. Another example of this time with the Event Bridge service. Again, very similar setup. For whatever reason, that particular endpoint, when interacted with, has access to production resources, so you can see everything that exists there, but you simply avoid all CloudTrail. Now, I'm sure you're wondering, how do you find non-production endpoints? It's a really good question. I've tried a number of things. I've tried brute force. I've tried looking at subject alternative names in TLS certs, looking at passive DNS, asking AWS very nicely, before eventually landing on what I think is probably the best, at least the fastest way to go about it, is to use certificate transparency logs. There is a fantastic open source tool called CertSpotter that allows you to monitor domains and subdomains for certificate transparency logs. And so I built some automation around that every time a new log is published for a domain or subdomain associated with the AWS API, the automation goes in, tries to validate that it is actually the AWS API, and then after, try and fingerprint what service it's associated with. And I have this automation running regularly. As it finds new things, I hand it off to AWS to be fixed. As it finds more endpoints that could be used for permission enumeration, I add it to a nice little database. And that has been a look at all of the ways that are publicly known to bypass CloudTrail. There is still a ton of opportunity out there to continue to evade CloudTrail logging, and there will be more research coming out soon showing other ways to get around it. For our purposes today, we took a look at protocol mutation, abusing the format and rigid structure of the AWS API so that we could silently enumerate permissions while avoiding detection. Then we took a look at undocumented APIs, using them essentially as a proxy to allow us to invoke normal APIs completely silently. And then we took a look at non-production endpoints and the world of opportunity they provide for defense evasion, but especially by changing the literal URL we're talking to, we can avoid CloudTrail. If you're a security researcher, I strongly encourage you to take a look at some of these techniques so that you can apply them to your own bypasses, or perhaps you'll find an entirely new way to evade CloudTrail. And with that, thank you so much. I'd be happy to answer any questions.
What happens if you try to create resources in the non-production endpoints?
So the question was, what happens if you try to create resources in non-production endpoints? It's a good question, and one that I struggle with for a while because it is kind of challenging. So for endpoints that do have access to production resources, they show up in the console, they show up when you query them normally. If it doesn't, it's almost like it exists in like an alternative dimension where like you can create stuff and you can talk to it as long as you use the right endpoint, but you're not going to see it in the console, you're not going to see it with the CLI or anything. Additionally, if you try and reference it, so like say for example, you did this with an S3 bucket and you're trying to have another service try and talk to it to store logs, it acts like it doesn't exist. So it's like an isolated environment almost. And that's why finding the ones that have access to production resources are great, because then you can interact with the real stuff, not like the other world.
Makes sense, thank you.
Mm-hmm.
What's your cat's name?
That is Bagheera. She is one of our babies. We also have a second cat named Cal, which I think is my current Twitter profile picture, but I might be mistaken on that. Yes?
Excuse me if I missed this at the beginning of your talk.
Sure.
I believe you said something about one of the things you found was something about multi-tenant crossover. I was curious, did you happen to go over that? And if so, did I miss it? Or
Yeah, no worries.
info about what you discovered that was cross-account?
Yeah, so the question was, I teased a bit about some cross-tenant research I did previously. I found a couple cross-tenant bugs. The most interesting one was for AppSync. If you search Security Labs AppSync, it'll probably come up for invoking, there's confused deputy attack in AppSync service. And then in addition for AppRunner, there was also an undocumented API that you could use cross-tenant. There were two of those that should also pop up if you Google it.
Thank you.
Yes.
Have you found that you can set like SCPs to block the undocumented APIs from running in your environment if you're automating, you're discovering them?
Yeah.
Right? What if you just automate that to block them, or is that going to break stuff?
Yeah. So the question was, can we use SCPs to, if I get this right, to prevent undocumented APIs or to prevent the use? Honestly, I haven't actually looked at using SCPs. That's a really good idea. I'll definitely look into that. Yes.
How does it behave against, let's say you have a interface endpoint or gateway endpoint that is set up to, let's say if you talk to secret manager, you have to go through this endpoint. How does it react when it talks to the non-production? Does it go through, does it force the traffic through the interface endpoint, or it just ignore that completely?
Good question. If I got this right, the question is, if you've set up like a VPC endpoint or a requirement to interact with a particular resource.
Right.
Yeah. Good question. As far as I'm aware, it will still require that you use that endpoint. But for things like, as an example for Secrets Manager, like list secrets, as far as I'm aware, you can't force, because it's not it's not a resource-based policy. It's an identity policy. As far as I'm aware, those would still go through just fine. If it's on the resource itself, it probably would require you to go through that VPC endpoint or that gateway.
Yeah, for example, like S3 gateway endpoint, right? Anything that calls AWS, S3 at Amazon AWS.com has to go through the channel. If it's invoked inside the VPC, has to go through the VPC endpoint. Just wondering if what happened if we call like non-production, if we also have the same.
Oh, and force it through?
Yeah.
Honestly, I haven't tried. That's a really good idea. There's so many different opportunities for messing with this. That's a great idea. Okay, anybody else? One in the back?
Yeah, I think mine's similar to his. You're using private endpoints as well as I think there's also a way now to prevent the use of high-end credentials without being internal to the AWS environment. There's a way to do that now. Something that might help to reduce the ability to enumerate.
Potentially, yeah. I thought I saw one more hand. Yes.
Have you done a similar assessment against Azure management APIs? And if so, do you have that published anywhere?
Yeah, so the question was, have I done any of this for Azure? Unfortunately, I'm only an AWS guy, but if anybody's into Azure or even, hey, GCP, feel free to try this. I've talked to some folks who've sort of carried over research I've done in AWS to other clouds, and they've had a lot of success. So if you're looking for finding some cloud vulns, you probably have a good shot. I don't see any other hands. Thank you so much, everybody.